everyone, I am Mohit. I'm from Meenakshi Institute of Technology, and today for my capstone project for Samsung Innovation Campus, I am presenting my project. The project's title is AgriGuard. The main problem statement was that farmers and people usually face a lot of issues when it comes to pests, and farmers, although they can see the pest, they cannot identify because they are very small in size. And on an annual scale, globally, we have 20 to 40% crop loss every year because of these pests. So even if we can identify them, we don't know which kind of pesticides or uh, actions we need to take. So for that, we built this project, and with this, we can upload a simple image that can be taken on your smartphone, and it can be uploaded to this. And based on that, it will predict which pest it is, and it will give you a summary from the knowledge base that we developed on our own. It's not from the database data set. So the data set that we used is IP102. It is a very difficult data set to work with because the images stored on it are not the lab images. They are images that are taken from real life under different lighting conditions. So it's a very difficult data set to work with. And it has 102 species classes and 8 crop groups, and the largest class contains around 5,800 images, while the rarest class consists of around 70 images. So this creates a very huge imbalance, approximately around 80 to 1. So the model gets very good at finding out common species, but not very good at finding rare species. So the model will miss out on the rare classes. So to tackle that problem, we used EfficientNet 50, which is already pre-trained on 1.4 million images, and to identify basic shapes and patterns. So we used our own training set of around 50,000 images to adjust it to our insect data set, and then to adjust the imbalance, we used macro F1, which treats all the classes equally. So even though there is a huge imbalance in this of around 80:1, there is no issue because all the classes are treated equally for the model selection using macro F1. And to adjust the loss, we used the focal loss with a gamma value of 2. And so I'll give you a demo of the project now. First, you select the image of the pest. Now this is the image captured on my own phone. Now here it gives you the classification which pest it is. It also gives you three other possible identity of that pest, because for the first, the one that is it's giving for the main classification, it might be wrong. That is why it is also giving out three other suggestions. Along with that classification, it also gives a basic information like the crops that it affects. This is given in the data set, and we use the GradCam to actually show which part of the image is driving that classification. Like for this one, the spots on the back is actually driving the classification of this pest. So we can also know, using the GradCam, we can actually know that which part of the image is actually driving the classification, because sometimes the background is what's actually driving the classification of the pest. Now this recommended control is not part of the dataset. It is a knowledge base that we developed on our own based on researching that 8 crop groups and the 102 species classification that was given in the dataset. This knowledge base is triggered based on the tag that the model gives when it finishes the classification. Now this dataset, now this knowledge base is stored in a JSON format, and it's only triggered when the tag is received from the model. So this was our project. Thank you.